Composite functions. We're going to do a whole bunch of different work with composite functions. We're going to add them together, subtract them, multiply them, divide them, and then do actual one function subbed into another. So, let's look at adding these functions. F at x plus g of x. Here's f at x, x squared minus 1, a parabola. Here's g of x plus 1. So when we add them together, you get x squared minus 1 plus x plus 1, which is just x squared minus 1 plus x plus 1, which is just x squared, then the plus x, and then the minus 1 and plus 1 cancel out. It's a parabola. You could leave it like that, or you can factor out an x, and you can see you've got another parabola, factor out an x, divide each term by x. So combining these two still left us with a parabola. What happens when we subtract them? That was when we're adding. What happens when we subtract them? Well, x squared minus 1 minus x plus 1. Put it in brackets, don't forget, because we're going to rainbow in a second. This negative goes on the x, and it goes on the plus 1, making it negative 1. So you end up with x squared minus the x minus the 2. And you can leave it like that, or if you want, you could factor and just think, what multiplies to negative 2 and adds to negative 1? Well, those numbers would be negative 2 and 1. So perfectly acceptable the way it was in standard form, or you can write it in factored form. Either way, when we went through the trouble of subtracting this g of x from f at x, we ended up still with a parabola. What happens when we multiply them? F at x times g of x. Put a line there, it's getting squishy now. F at x times g at x. Better recenter that. Well, x squared minus 1 times x plus 1. And now let's rainbow or foil. X squared times x gives x cubed. X squared times 1 is plus x squared. Negative 1 times x gives negative x. And negative 1 times 1 gives negative 1. So when we multiplied them, got a brand new function, in this case of a totally different parent function, a cubic. Let's see what happens when we divide. Well, f at x is x squared minus 1, and g at x is x plus 1. This is going to be a rational function now. We can leave it like that, but better would be to simplify. X squared minus 1 is a perfect square made up of x minus 1 times x plus 1 all over x plus 1. And I hope you remember from your rational function days, this means there's a hole at x plus 1. So we can simplify this equation. It's going to be a line, x minus 1. These factors cancel out, but make sure to save the restriction. This is the line y equals x minus 1, but x can't be negative 1. At negative 1, there's a hole. The last one we'll do is f at g at x. Forgot a bracket here. And so f at g at x means sub g of x into f at x. So I'll start by writing what would have been f at x, but don't write it yet, I'm going to erase it. F at x is x squared minus 1. But subbing in g of x into the x of f at x is what this means. So take g of x, which is x plus 1, and put it in place of f's x. F's x was x squared, so instead of this being x squared, we replace the x there with g of x. I'll put it in brackets. This is x plus 1 squared now. And let's simplify. You get x plus 1 times x plus 1 all minus 1. Let's FOIL. X squared, put a line here. X squared plus x, just foiling, plus 1 minus 1. And so I end up with x squared plus 2x, and then this plus 1 and this minus 1 cancel out. Didn't know necessarily what I was going to get there, but it turned out I still got a parabola. Can leave it like standard form, or I can factor out an x. And there you have it. Notice up here I wrote the formulas as f plus g at x, f minus g at x, f times g at x, f divided by g at x, and f at g at x, which can also be written as separate functions: f at x plus g at x, f at x minus g at x, f at x times g at x, f at x divided by g at x, and f of x at g of x.